Hello friends, welcome to Civil Mantra. In this video, discuss about property of Fourier transform. We have already discussed linear property, change of scale property and shifting property. In this video, we discuss about two properties, modulation theorems and convolution theorem. So discuss firstly modulation theorem. In this modulation theorem, if f of p is a function of a Fourier transformation is the complex Fourier transform of f of x, then the final result, this is formula of the modulation theorem, f, this is transform of fx and cos ax bracket 1 upon 2 fp plus a plus fp minus a. This is our modulation formula. When we seen this is proof, how can you prove this is modulation theorem and result find this? So seen, we have considered only left hand side. When you consider left hand side, you know also f of x equal to minus infinity to infinity. This is the basic formula, fx minus e to e raised I p x and f of x and dx. But we seen in this formula x is considered the whole term because f of x and cos x. So solution this equal minus infinity to infinity e raised I p x f x and cos a x dx because it's whole term in x. Next, minus infinity to infinity e raised I px f of x adds fx cos ax. In a complex formula already discussed some standard results. So we retain e raised I ax plus e raised I ax minus 2 and dx. 1 upon 2 constant term, 1 upon 2 minus infinity to infinity e raised I p x f of x and dx. When you apply this whole term this integration, show positive sign epx and ebx. In this product formula, तो EPX को we can write EP AX यानी P plus A X and FX DX. We can write positive sign minus AX and IPX. So minus infinity to infinity e raised I P minus A and X FX and DX. Okay, 1 upon 2. This is our the basic formula. When you compare this formula minus infinity to infinity e raised I p plus a x fx adds dx adds. So we can write f of p plus a and f function p minus a. This is proof our final results. Okay. Now, secondly discuss convolution theorem and also we seen how to prove this formula. Convolution theorem. What is convolution theorem? Convolution theorem of the two function. Suppose The basic definition of a convolution theorem: the convolution of the two functions fx and gx over the interval minus infinite to infinity is defined as f star g. This is, say, f convolution g minus infinity to infinity f of u and g x minus u du equal to final result h x. This is statement also we discuss about convolution statement. This is statement: our Fourier transformation of the convolution f of x and g of x is the product of their Fourier transform. This is f Fourier transformation f x convolution gx equal to f, this product first x and the gx. This is f transformation fx into f transformation of g of x. So how can you prove this formula? So Susheen, prove. Our consider the left hand side f of x convolution g x. Okay. When you consider this final only x, so the basic formula of the Fourier transformation f of x minus infinity to infinity e raised I p x and fx into dx. So compare this formula. This is total form this x. So also we can written this f of x and the g of x. So written minus infinity to infinity fu g x minus u and du. Okay. F of x, total term in the x, again minus infinity to infinity. This is minus infinity to infinity. F of x and gx. So we can write f of u and g x minus u and du e raised I p x and dx. Okay. Next, this constant term on changing the order of integration, because this is x term and this is x and this is u and the u. Our integration in the x term, so minus infinity to infinity f of u outside and the bracket minus infinity to infinity g x minus u e raised I p x dx and du. No any change, only changing the order of the integration. Okay. Next solve this minus infinity f of u. This is minus infinity to infinity g x minus u and e I p x dx and du. This is x minus u. X minus u equal to t, differentiate dx equal to dt. So put in this form gt and gt e raised I. When you form x to t plus u, x consider t plus u. So p x t plus u in this dx equal to dt, dt and du. When this solve next, minus infinity to infinity f of u bracket minus infinity to infinity in this gt e I p t into e raised I p u dt and du. This is the u term and this is u term. Out in this bracket minus infinity to infinity f of u and also written I e raised I p u. Okay. I p u bracket minus infinity to infinity IPT, e raised IPT, and GT and DT into DU. So this is our final formula in Fourier's transform. Also we written is this minus infinity to infinity f of u e raised IPU, and this is du, and this is formula in Fourier transformation. So also we written f and g in term of t. Okay, अब this is formula in this u term. So also we written this is Fourier transformation, e raised IPX, and this is fx in term of fx. One step minus infinity to infinity f of x. Also we written I raised IPX and dx interchanging property f bracket gt and this. So also written f of transformation f transformation fx written and f transformation gx gt and this. The final result in this proof, the product of the transformation of the convolution f convolution g into the product f transformation f of x and f transformation of g of x. So proof only those x term, this is changing in the x interchanging property, both are in x term. Okay, x term. So f of x and g of x. When you seen all video, so also like, share and comment. Thank you for watching this video.